Welcome. This is another Khan Academy support video. Specifically, we're going to be looking at our first Khan Academy assignment this week, the one that's called Solutions to Two Variable Equations. So we're going to go ahead and open that up. Before we start looking at the first problem, since it's the first assignment, I want to talk on my whiteboard about changing our definition to a solution. So we make that whiteboard a little bit larger. Previously, when we talked about solutions, our equations had just one variable. So for solution, we talked about a solution was the value for the variable that made the equation true. Today, and all week, we're going to start looking at equations that have two different variables at the same time, an x and a y in the equation. So when we have what I'm going to call these as linear equations as we work more, but when we have these linear equations or two variable equations, a solution, our definition has to change a little bit. Now a solution is going to be a pair of values for the x and y, so our solution is going to have two numbers to it, one value for x, one value for y. And when you plug in those x and y numbers into the equation, that needs to make the equation a true statement in order to be a solution. So in this first example, and let's make the whiteboard a little bit smaller now, in this first example, we're given the equation negative 7x plus 3y is equal to 2. And Khan Academy asks us which ordered pair is a solution of the equation. So they're not asking us to solve this equation, they're saying which of these possible pairs could be solutions to that equation. We see 1 and 3, negative 2 and negative 4, and option C says both of them, option D says neither. So the first thing we need to understand about ordered pairs, whenever you have an ordered pair, which I'm writing at the bottom of my whiteboard, the first number represents x and the second number represents y. So our very first solution that they offer, when they offer the solution 1 and 3, they're saying can x be equal to 1 and can y be equal to 3. So I'm going to plug those numbers, that 1 and that 3, in for x and y into the equation. It's going to change to negative 7 times 1 plus 3, and now 3, which multiplied with y, I'm going to replace the y with 3. So to test whether this 1 and 3 would be a solution to our equation negative 7x plus 3y equals 2, I need to plug in the 1 for x and I need to plug in the 3 for y. Now at that point, there are no variables left in the equation. I'm going to just follow order of operations, or PEMDAS, to help me figure out, is this a solution to that equation? Does it make the left side equal to the right side? Negative 7 times 1 gives us negative 7. 3 times 3 gives us 9. So the left side of the equation becomes negative 7 plus 9, and we need that to equal 2 if this is going to be a solution. Negative 7 plus 9 gives us 2. So 2 is equal to 2. So I'm going to just put a little note at the bottom here. 1 and 3, that first solution set that we tested, is indeed one of the solutions or one of the possible values that works for x and y in this equation. Now the other solution that they want us to test says test negative 2 and negative 4. I'm going to put that over here on the other side. So this time we're going to go ahead and take that same equation, and now instead we're going to plug in for x and y a negative 2 and a negative 4. Because we know that A works, but we also need to know, does the ordered pair for B work? Negative 2 and negative 4. So I'm going to replace my x with negative 2. That becomes negative 7 times negative 2. And I'm going to replace my y with negative 4. Now that the variables have been substituted out, we follow order of operations to simplify. Negative 7 times negative 2 gives us positive 14. 3 times negative 4 gives us negative 12. And we need that to be equal to 2. 14 plus negative 12, that gives us positive 2. So I see when I plugged in this other option, negative 2 and negative 4, the other possible solution they offered us, I see that also made the left side equal to the right side. So that tells me that both of these are in fact solutions to that equation. We'll go ahead, we'll check if that answer is correct. We see that it's correct. Here you see their explanation. They kind of go for all of these. They'll show you very much what you're seeing on my whiteboard. They take the equation and they plug in the x and the y value to see if it works when it's substituted into the equation. So now we see our next equation here. So for problem 2, they tell us 7x minus 5 has to be equal to 4y minus 6. So I'm going to go ahead and copy that equation onto my whiteboard. 7x minus 5 needs to be equal in value to 4y minus 6. And the two solutions that they want us to test here, they want us to test whether or not 2 for x and 4 for y could be a solution. So that's one possibility we're going to check. And they also want us to check whether 3 and 6 could be a solution. So I'm going to go ahead and first plug in that 2 and 4. I'm going to make x equal to 2. Remember, always ordered pairs, the x is listed first. So I'm going to plug the 2 in for x. 7 times 2 minus 5 is equal to 4 times y. But now again, I'm going to be plugging in when I make the x 2, I'm going to test can y be 4. Once I've substituted the 2 in for x and the 4 in for y, I'm going to evaluate or do the math. First thing I'm going to do is multiplication. 7 times 2 gives me 14. So the left side becomes 14 minus 5. On the right side of the equation, I'll do 4 times 4, which gives me 16. And I still need that negative 6. Simplify by doing the subtraction on both sides. 14 minus 5, that gives us 9. 16 minus 6, that gives us 10. So when I plugged in 2 for x and 4 for y into this equation, I was left with 9 equals 10, something that's a false statement. So based on that, I know 2 and 4 is wrong. That cannot be a solution to this equation. The other solution pair I need to test in this equation is 3 for x and 6 for y, so I'm going to go ahead and plug that into my equation. So we'll replace the x this time with 3. It becomes 7 times 3 minus 5. And on the right side of our equation, in the right expression, 4y becomes 4 times 6. 7 times 3 gives us 21 when we do the multiplication on the left side of our equation. 4 times 6 gives us 24 on the right side of the equation. Now we'll do the subtraction. 21 minus 5 gives us 16. 24 minus 6 gives us 18. And we're left with another false statement here. When I plugged in a 3 and a 6 for x and y, it didn't work in the equation either. I was left with 16 equals 18, another false statement. So there are solutions out there in the world to this linear equation. We'll talk about how to find all the solutions and make graphs of them later. But for now, 3 for x and 6 for y would not be a solution to this equation either. So I'm going to go ahead and select answer choice D, which says neither 2 and 4 nor 3 and 6 work as solutions to this equation. For the remainder of these problems, they're all very similar for this assignment, so I'm not going to keep providing more examples. If you need help, I would encourage you, the basics are start by writing down the equation, plug in the values for x and y, and then follow order of operations to see if that solution works. If you still need help, please watch the video from Sal Khan. Please read their explanations, and as always, feel free to send me an email, and I'm happy to get back to you with Google Meet and some help one-on-one. Have a great day. Thank you for the hard work so far.